Is anything due Friday?
Again, this is the last packet. We'll say that this packet is due Friday on test day. And again, I'll work half of them and assign the other two basically each day for the free response days. There's also some multiple choice in there where we can play the game or just go through them as well. So Friday's test, though, is all free response. Because the last time we took a practice test, it was all multiple choice. So we'll kind of mix it up a little bit. All right, I'm going to do 1 and 2, and then if we have time, I might do 5. 5's kind of easy. It already says to omit 2D, but I need you to omit 1D as well. So you can mark out 1D, 2D is already marked out, and 4D you can mark out as well. So some of these are pulled, I guess all of these were pulled from BC test. All right, so let's do number 1 and 2. FRQ topic 6. Researchers on a boat are investigating plankton cells in a sea. The density of plankton cells in millions of cells per cubic meter. Okay, this is a weird unit here. This is definitely a calculator problem with that weird equation in there, where P is the density of plankton cells in millions of cells per cubic meter. So that's not a real common unit right there, millions of cells per cubic meter. And H is in meters. So we've got some formula that tells us how dense the plankton cells are based on how deep we are in the ocean or the sea. This model is for H between 0 and 30. And F of H for when H is greater than 30. But we don't even know what F of H is. So I don't know what help that is yet. The continuous function is not explicitly given. Okay. So they don't give it to you, and then they tell you they don't give it to you. Part A, find P prime of 25. And interpret the meaning of that in the context of the problem. Well, that derivative at 25. We'll worry about the meaning in a minute. Since this is a calculator problem, I'm going to guess that I'm going to need it multiple times, so I'm going to put that in for y1. 0.2 x squared times e to the negative 0.0025 x squared. 0.2 x squared e to the negative 0.0025 x squared. Okay, weird unit. Window, I already know I can go 0 to 30 for the x. I have no idea what the y unit should be, so I'm just going to graph it negative 2 to 10 and see what. Okay, so that's way off the page. So my y max should be much bigger. Let's see what that does. Got a little too ambitious on that one. Not that big. Window, y max 100 maybe. There we go. That's reasonable. I guess I could change it to 50. I don't know. Probably shouldn't spend too much time messing around with a window. But you do want to, what you look at, you want to make sense of. All right, P prime at 25. So second calc, derivative at 25. So my answer is negative 1.179. Now, if I could put units on that, that would really help me explain what in the world that means. P prime would be dp dh. Maybe that would help with units. So P is millions of cells per meter cubed. Per meter, because the H is in meters. Now you could make that millions of cells per meters to the fourth, but that really wouldn't make sense in terms of the problem. So P prime is how P is changing with respect to H. So let's see. P is density of cells per meter cubed. Whoops, density of million cells per meter cubed is changing at a rate, like that's probably the key words they're looking for, changing at a rate of negative 1.179. This is just a weird problem. Million cells per meter cubed over meter when or at H equals 25 meters. So I think that's a sufficient answer for part A. I want to try to convince myself the density is going down. It's like the density increases to whatever that maximum is, and then after that, the density of cells decreases. Part B. Consider a vertical column of water in this sea with horizontal cross sections of constant area 3 square meters. So a vertical column of water, the cross-sectional area is 3 meters squared. To the nearest million, how many plankton cells are in this column of water between H equals 0 and H equals 30? So I want to add up. Maybe we should just figure out how many are in that slice. So P is in million cells per meter cubed. So I need to multiply by the area, which is 3 meters squared. That would get me to million cells per meter. And then if I wanted to multiply by the thickness, but that thickness is just dH. So adding them all up is integrating. Add them all up from 0 to 30. The A is equal to 3, so I can just put a 3 out front. And then integrate P of H dH. P of H is already defined, so all I need to do is type this in the calculator. Math 9. Whoops. Multiplied by 3. You can do it later, but I'm doing it now because I'm afraid I'll forget it later. So P was our Y1 bars. So it's an easy thing to put in the calculator. It's a hard thing to understand what they're asking you to find. So 1675, although what did it say? To the nearest million. So 1675 million cells in that column of water. Part C. There is a function u such that f of h is more than 0 but less than u of h, and 30 to infinity u of h dh equals 105. So they've integrated, so they're adding up all of the plankton that's in there from 30 to infinity, although this was million cells per meter cubed times meters, so that 105 would be million cells per meter squared. I don't know if this is going to matter or not. Because we multiplied by dH. Again, I'm not sure that's going to matter, so let's keep going in this problem and see what it asks for. The column of water in part B is k meters deep, where k is greater than 30. Write an expression involving one or more integrals that gives the number of plankton cells in millions in the entire column. Okay, well, we already found the 0 to 30 cells. That was 3, 0 to 30, P of H, dH. Involving one or more integrals. Oh, that's good, because it's going to take more than one integral. Because then I want to integrate from 30 to infinity. Of, do I use F or do I use U? I need to use F, because F is what models how many there are. I don't even know F, but I need to use F. Oh, I need to put a 3 on there to account for how the surface, or the area of the cross section. Explain why the number of plankton cells in the column is less than or equal to 2,000 million. Well, we already found this part. That was 1675. And I don't know this, but I do know that U, so if we use U, that'd be 3 times 105. I think how to best explain this, though. Cells using U of H, 1675 plus 3 times 105 is 1990. But they told us that F of H is less than U of H. So the number of plankton cells is less than 1990. Because we used, with U of H we got 1990 total. But F is less than U, so our total is going to be less than 1990. Does that make sense? Yes, no? I mean, that's just one of those, like, it's kind of tricky. It's not explicitly calculus, really. It's just, here's the total with u, but the real total is less than that, so I guess the real total will be less than 1990. So kind of a tricky one. Again, you don't got to get them all right. You got to get hopefully more than half the points on each of them, and hopefully hit a couple of free response that really click and you can do well on. I think number 2 will qualify as one we can do well on. Seems pretty straightforward. There's no crazy units involved. F of x is that fraction. Find the slope of the line tangent to the graph of f at x equals 3. I'm going to guess this is no calculator. In fact, because it's number 5, it would have to be no calculator, since the first 4 are with, or the first 2 are with calculator, and the second 4 are no calculator. So this would be a no calculator question. Part A, find the slope of the line tangent to the graph of f at x equals 3. So I need f prime at 3. I think I want to rewrite this so that I can take an easier derivative. I mean, you could do quotient rule if you want, but you can rewrite it and then you don't have to do the quotient rule. So I'll let you decide which one you'd rather do. But I'm going to avoid the quotient rule. So negative 3, 2x squared minus 7x plus 5 to the negative 2 times, what do I have to remember? Chain rule. I saw a calculus teacher in my favorite Facebook group. He said he writes ABC on most of his tests, and his students know that that means always be chaining. Silly things we do to try to get you to remember the chain rule. Tootsie Roll Pops, ABC, whatever. Always be thinking about, I got to remember the chain rule. So let's see, that would be 4x minus 7. And if I want to clean that up a little bit, negative 3 times 4x minus 7 over all of that squared. And if you think back to the quotient rule is gf prime minus fg prime over g squared. So there's my g squared in the bottom. So I think quotient rule would hopefully give me the same thing. So f prime of 3. I sense a safe stop coming on. Right? Like, I don't want to mess with that. I don't know what that is. I don't want to know what that is. It's f prime of 3. That's the slope of f at 3. The slope of the tangent line at x equals 3. And that's all part A asked for. So thank you very much. I don't want to calculate that, especially on the no calculator section. I really don't want to. I mean, all that looks easy, but why take the time and risk it? Leave it alone. Part B, find the x-coordinate of each critical point of f in the interval 1 to 5. Critical points. That would be where f prime is either 0 or undefined. Okay, well, we have f prime. So f prime equals 0 when the top is equal to 0. So the negative 3 wouldn't give me anything, right? I can't set that part equal to 0. Set 4x minus 7 equal to 0. So 7/4 is a critical point. And it said it only wanted in between 1 and 2.5. I'm not sure why that is, but 7/4 is bigger than 1 and less than 2.5, so that counts. f prime undefined would be where the denominator equals 0. Oh, please, did they give us one that factors? Right? Multiplies to 10, adds to 7. There's nothing that does that. There's no way, I don't think. Oh yeah, 5 and 2. I did that wrong, didn't I? Because we want them both to be negative, and then 1 and 5 like that. Yeah. So x equals 5 halves and x equals 1. Oh, now I see why they put that. Look really carefully at what it says. Find the x-coordinate of each critical point between 1 and 2.5. Are we including 1 and 2.5? We are not including. So that was kind of them. Those are not on the interval. I mean, they're almost there, but because of the not equal sign there, we can throw those out. And man, that's a big hint that we're on this problem. We're doing this problem right, that we landed exactly on the endpoints. That seems not an accident. So I don't have to worry about those. So the only critical points on my interval, critical points on 1 to 2.5, is only x equals 7/4. So I mean, I don't want to just mark all that out, because I need to show that I know that there's critical points there. In fact, it's probably a point for recognizing them and throwing them out. So I'm just worried about 7/4. Relative minimum, relative maximum, or neither, justify your answer. How are we going to number line? First derivative test with a number line. First derivative test. You don't have to explain what you're doing, but wouldn't hurt. 7/4. So let's pick something less than 7/4. We better be careful though, because something's going on in here. We better pick something on our interval, because let's pick something not 1, because 1's going to make the bottom be 0, and that's going to be a problem. So I need something bigger than 1 but less than 7/4. How about 1.5? Yeah. And then bigger than 1 but less than 2, or excuse me, bigger than 7/4 but less than 5 halves. 2. That's a little easier one there. All right, so f prime at 1.5 is -3. 4 times 1.5 minus 7. Now the bottom looks ugly, but what do we notice about the denominator of f prime? What's that? Why doesn't it matter? Well, I mean, the 1 and the 5 halves don't matter because they're not on the interval. But it's squared, so it's always going to be positive. So I don't have to worry about plugging things in there. I'm just going to write positive down there, because all I care about is plus and minus. So 4 times 1.5. I don't have a calculator, but I can do 4 times 1.5. I think. That'd be 6. Minus 7 is -1. Negative times negative is positive. So f prime is positive. That means f is increasing. Be careful about what you're saying there. F is increasing, f prime is positive. A little arrow going up if you want. Guessing 2 is going to be negative, but who knows? So let's plug in 2. Again, denominator is always positive, so I don't have to worry about it. So f prime is negative. So f is decreasing. So what's going on at 7/4? There is a relative max. Because, okay, all the picture is great, but the picture doesn't get you points. You have to put it in calculus words. So why is there a relative max at 7/4? F prime changes from positive to negative. Again, know what to write. They're not looking for a paragraph explanation. They're looking for a good calculus reason to explain the answer. All right, let's make sure we classify each critical point as a relative min, relative max, or neither. Justify your answers. We did all that. Part C. Using the identity that 3 over... Okay, this is interesting that they did this, because breaking that fraction apart like that, that is a skill that they do in Calculus VC. So they did not have to do that for them. College Board could have just said, use partial fraction decomposition. That's the fancy word for it. And we did that in pre-cal, where you set this up as a over 2x minus 5 and b over x minus 1. I guess they just didn't want to force the students to figure that out or take the time to do it. So they just give it to you and say evaluate from 5 to infinity f of x. So I'm just going to go ahead and put those in there. Infinite limit, which seems kind of weird. Let's just see what happens here. What's the integral of 2 over 2x minus 5? You can do u substitution if you like, but you might recognize what it is. It's du over u. In fact, no adjustments are necessary because they put a 2 up there for us. So that would be natural log of 2x minus 5. Minus. How about the natural... Oh, that just gave away the answer. The integral of 1 over x minus 1. The natural log of x minus 1. Oh, I forgot. You could probably get away without them, because if your number is always bigger than 5, then you're not going to have to worry about absolute value bars. So I could have forgot them and it wouldn't have mattered. And then I want to evaluate that from 5 to infinity. Infinity is going to be a problem, right? Natural log of infinity. Infinity graph looks, or the natural log graph looks like that. So it goes to infinity. What about a property of logs? So some algebra. Okay, now what happens if I plug in infinity? What do I get? This is almost the top no, bottom O equal co kind of thing here. I get 2, or at least 2 in the inside there. So that'd be natural log of 2 minus, plug in 5. That'd be natural log of 5 over 4. And I would leave that as my answer. I mean, there's more algebra, but we're done. Don't do algebra if you don't have to. So that was kind of a weird problem there, but stuff combining different pieces. Like College Board's always really good at pulling in different information. All right, I want you to try the rest of them, 3 through 5. I don't have the answers posted yet, but I will. And again, don't get discouraged as you work them. Hopefully you can squeeze out some points out of them and get something. Oh, look at the time. We did 2 free response questions. 30 minutes. And that was kind of slowing down and explaining. And so, again, time is not usually the issue. You know, if you spend 10 minutes staring at something because you don't know it, well, that's a problem. But that wasn't a time problem. That's a knowledge problem.